Okay, since the other video was having a problem, I'm going to make a new one for finding the second derivative of a given function. So the function is y equals x over the square root of x minus 1. The idea is basically simple. You get the first derivative and then you get the second derivative after. The problem becomes complicated only because of the given expression. So let's start with finding the first derivative. Okay, so let's have the y equal to x over the square root of x minus 1. So to get the first derivative, so we apply the quotient rule. So I have the square root of x minus 1 times 1 minus x times derivative of the square root of x minus 1, which is 1/2, then x minus 1 to the negative 1/2. And then basically there's times 1, but we don't need to put that anymore. And then everything over the square of x minus 1, which is just x minus 1. And then you simplify it, so you have the square root of x minus 1 minus x over 2. So x times 1/2 is x over 2. X minus 1 to the negative 1/2 is the same as 1 over x minus 1. So this is the same as 1 over x minus 1 to the positive 1/2. But raising to positive 1/2 means square root. So this is the same as the square root of x minus 1. And then everything over x minus 1. And then you simplify this. This is the same as the square root of x minus 1 minus x over 2 square root of x minus 1 all over x minus 1. The next thing that you need to do is to simplify the numerator. When you simplify the numerator, you just combine these two expressions. So I can take the LCD of the numerator as 2 square root of x minus 1. Then when you divide this by, so this is over 1 by 1, so that will be itself, and then times this. So you can see a 2 times square root of x minus 1 times square root of x minus 1. So again, so divide by 1, that's 2 square root of x minus 1. And when you multiply it by the square root of x minus 1, this will be 2 times x minus 1. So you have 2 times x minus 1 minus this divided by itself will be 1 times x, so you have x. Then over x minus 1. Then you simplify it, so this is 2x minus 2 minus x, and then over the 2 square root of x minus 1. And then I want you to follow how I will be simplifying the over 1 over the x minus 1. This is the same as times 1 over x minus 1. And then you can still simplify the numerator here. This is x minus 2 over 2 square root of x minus 1, x minus 1. Now, there's still a way to simplify this. Take note that square root, so take note, so if I have x minus 2 over the 2 square root of x minus 1 times x minus 1, this is the same as x minus 2 over 2 x minus 1 to the 1/2, and then x minus 1. Now, since these two have the same base, and that means you can write it in a single base, so that you still have the 2, then you have x minus 1, and when you combine the two and you multiply the two, you add their exponents. So 1/2 plus 1 will be 3 over 2, and then you have x minus 2 on the numerator. Now at this point, I will not be requiring you to write this back into a radical expression. So this is the first derivative. So to find the second derivative, all you have to do is to differentiate this again. Now during the assessment, I will not be requiring you to simplify it further once you apply the rule for derivative, the quotient rule for this function. Okay, so let's take note of the expression first. This is x minus 2 over 2 x minus 1 to the 3 over 2. Okay, so this is what we got for the first derivative. It's x minus 2 over 2 times x minus 1 raised to 3 over 2. So to get the second derivative, all we have to do is to differentiate the first derivative. So this is still a quotient of two expressions, so we just have to apply the quotient rule. So that's 2x minus 1 raised to 3 over 2 times 1 minus x minus 2, and then we differentiate this. This is 2 times 3 over 2 x minus 1 to the 1 half times 1, everything over the square of 2x minus 1 3 over 2. Okay, so just be careful when you simplify. So just make this 2, this is just times 1, so you have x minus 1 to the 3 over 2 minus, just cancel what you can cancel. So this is 3 and 1, that's 3. Then you have x minus 2, and then you have x minus 1 to the 1 half, all over 4, that is 2 squared. And then when you square the 3 over 2, the expression x minus 1 raised to 3 over 2, the 2 and 2 will cancel. So you have x minus 1 to the third. Okay, now to further simplify this, focus on x minus 1 to the 3 over 2 and x minus 1 to the 1 half. So basically you have you have a common factor here, and that is x minus 1. So remember, whenever we factor out something, we have to factor out the smaller one. And in this case, the smaller one is x minus 1 to the 1 half, because 1 half is smaller than 3 over 2. So I'll factor out x minus 1 to the 1 half, and that will mean you have 2 left here, and then you have x minus 1. If you subtract 1 half because you're factoring out 1 half, then this becomes 2 over 2, or 1. And then minus 3, and then you factor out x minus 1 to the 1 half, then you have x minus 2. And then you have 4x minus 1 raised to 3. And then all you have to do is to simplify this. So you have x minus 1 to the 1 half. The parenthesis will become, this is 2x minus 2. This is minus 3x plus 6. And this will be negative x. And you have negative 2 plus 6 is positive 4. All over the 4 over x minus 1 raised to 3. And then finally, you have x minus 1 and x minus 1. If you take away x minus 1 to the 1 half, that means you're taking out x minus 1 to the 1 half also in the denominator. So if you take away 1 half from 3, that will be 3 minus 1 half, or 5 over 2. And this will be the simplest form, negative x plus 4 over 4. So you have 4, then x minus 1 to the 5 over 2. You can still make this in the form of a radical expression, but I can already accept the answer in this form. Okay, so that's it.